Hey, welcome to Trixel. In today's video, we'll be discussing a very interesting use of calculus, finding the volume of 3D objects, but we'll do it in a very interesting way. Let's start by drawing a 2D graph. And on this graph, we can sketch the curve of y equals x squared. So right now, as you can tell, we start with a 2D curve, but how can we transform this into a 3D object? We can do this by rotating the curve around the y-axis. And if we do this a full 360 degrees, we'll find ourselves making an upside down dome kind of object. Now how can we describe this object? If we look at the makeup, it's just a bunch of circles or discs stacked on top of each other. Between the y intervals, there's an infinite amount of disks, as illustrated. But what can we tell about these circles, or disks? We know that there's an infinite amount, but we also know the radius of each one. The radius of each disk is just the x value that is dependent on the y value. So we can actually rearrange our formula and solve for x in terms of y. And that gives us the radius of any given disk at a certain y value. Now if we want to find the volume at an interval of this object, we have to define a starting y and an ending y. We'll find the volume from y is equal to 0 to y is equal to 5. Now how can we do this? We can do this through integration. We know that integration is the sum of an infinite amount of planes through an interval. We can find the interval from y equals 0 to y equals 5, and we can add together all the circles. But what's the area of a circle? The area of a circle is pi r squared, and we know the r because it's just the square root of y. So now let's integrate from y equals 0 to y equals 5 of pi the square root of y squared dy. And this is equal to 12.5 pi. So this is a really basic overview of the disk method, a method in which you can find the volume of 3D objects by stacking an infinite amount of disks or circles in an interval and adding them together through integration. There's a lot of other applications for this. You can also find the volume of objects not only rotated around the y-axis, but also any line you want, or maybe even the x-axis. And it all happens through integral calculus. Thank you for watching this video. If you have any calculus concepts or questions you'd like to ask, just leave a comment down below and I'll do my best to make a video on it. Thank you for watching. I'll see you in the next video.